In the late morning of August 9, 1945, in northern Kyushu, Japan, a 24-year-old Tetsuya Fujita quickly led his students toward an underground air raid bunker. The young professor glanced at the sky, but a thick layer of clouds obscured the aircraft. A B-29 superfortress laden with a single atomic bomb.
The primary target was 3 miles from where Fujita was. The bomber actually made 3 attempts to drop its load. It could not get a visual because of the clouds, so they ended up going to their secondary target, which was Nagasaki. The cloud cover over his city really spared his life.
At 11:02 a.m., the B-29 dropped an atomic bomb on Nagasaki. Thousands of buildings and homes were instantly destroyed. The flash radiation of heat from the blast scorched hillsides as far as 8,000 feet away from ground zero.
About a month later, Fujita was asked as part of a team to go out and look at the damage pattern around Nagasaki and Hiroshima to see if they could determine exact location of where the bomb detonated and the altitude of the detonation.
After closely examining the debris, Fujita and his colleagues calculated that the bomb had exploded 520 meters above the ground. But what intrigued Fujita more was the curious pattern left by the blast. The blackened trees directly below the explosion stood upright, while those radiating out from ground zero fell away horizontally in a starburst pattern. As he studied the damage, Fujita imagined the airflow from the blast descending rapidly and fanning outward upon contact with the ground, toppling the trees.
This was his first really comprehensive damage survey. It wasn't meteorological, but some of his early understanding of how to do a damage survey. Those seeds were planted during these surveys of these 2 atomic bombs.
In the ashes of Nagasaki and Hiroshima, Fujita realized that the rubble told a story beyond the tragedy of death and destruction.